Okay, let's dive right into this. Welcome to today's Explainer, where we are pointing our focus toward the second planet from the Sun, our closest planetary neighbor. We're talking about Venus. This is a world that is, well, completely terrifying, undeniably fascinating, and honestly a masterclass in extreme planetary environments. We're going to peel back the thick, toxic clouds of Venus today and look directly at the nightmare that lies beneath.
Just look at the track record of the Soviet Venera probes that were sent there between 1961 and 1984. Only a handful managed to even function after landing in this incredibly hostile environment. And the absolute record for survival? Just 2 hours. 2 hours before the probe was completely cooked and physically crushed by the planet. No way around it. Venus plays absolutely rough.
Section 1. Earth's evil twin. The similarities and its size.
So you might be wondering, why call it our twin at all? Well, about 4.6 billion years ago, Earth and Venus were born from the exact same swirling disk of gas and dust. If you were to slice both of them in half, they'd look remarkably similar. They each have an iron core enveloped by a hot rock mantle, all topped with a thin rocky crust. So the really crucial question here is this. How did two planets, starting with such incredibly similar building blocks, and even oceans in their younger days, end up on completely opposite paths? One becomes a beautiful paradise teeming with life, and the other, well, it becomes an absolute inferno.
The contrast is just staggering. On one side, you have our comfortable, life-sustaining Earth, and on the other, Venus. We are talking about average surface temperatures around 872 degrees Fahrenheit. That's 467 degrees Celsius. That is literally hot enough to melt lead. It's completely wrapped in dense clouds of toxic sulfuric acid, and the atmospheric pressure is a whopping 93 times what we experience at sea level.
Actually, before we descend into that toxic atmosphere, I want to briefly touch on a slightly lighter topic. Venus doesn't actually have any moons, but it does have this quasi-satellite officially named Zuzve. It's a small asteroid, maybe 660 to 1,640 feet across, that's been hanging around Venus for at least 7,000 years. And the best part about it? It originally had this boring provisional name 2002 VE68, but an artist who was drawing a children's poster of the solar system misread his own handwriting of 2002 VE as Zuzve. The name just kind of stuck, and the International Astronomical Union actually went ahead and officially approved it.
Section 2. The toxic skies. A crushing, acidic atmosphere.
Time literally works differently here. Venus spins incredibly slowly. And get this, it spins backward compared to Earth. That means the sun rises in the west and sets in the east. A single rotational day on Venus takes 243 Earth days, which means its day is actually longer than its entire year, which only takes 225 Earth days to complete. Because of this totally backward, sluggish rotation, the time from one sunrise to the next is about 117 Earth days. It is completely mind-bending.
93 times. As you plunge through the mostly carbon dioxide atmosphere, the pressure builds relentlessly. By the time you hit the ground, the pressure is 93 times that of Earth. To put that into perspective, walking on the surface of Venus would feel exactly like being squeezed by the crushing force of the ocean if you were more than 3,000 feet underwater. But here is a fascinating twist. While the surface is this blistering 872-degree hellscape, if you go about 30 miles up into the clouds, the temperatures drop to a very Earth-like 86 to 158 degrees Fahrenheit, and the atmospheric pressure is actually similar to our own surface. Astrobiologists have noticed mysterious dark streaks in these clouds that absorb ultraviolet radiation. Could it be Venusian microbial life? If so, they might survive by wrapping themselves in chemical cloaks made of ring-shaped linkages of sulfur atoms to protect against all that sulfuric acid. It completely redefines what we consider a habitable zone.
Section 3. A volcanic wasteland. 80% of the surface is volcanic plains.
So, we plunge completely through that sulfur-yellow sky and arrive at a barren, rocky landscape that has been entirely reshaped by extreme, global-scale volcanism. There are over 1,100 volcanic structures larger than 20 kilometers in diameter identified on Venus, and likely many thousands more smaller ones. And what's really amazing is how staggering the preservation is. Because Venus completely lacks water, its crust is actually incredibly strong, meaning these geologic structures are just beautifully preserved over massive stretches of time. As we map the surface using radar, we discover massive features known as fluctus. Just imagine flood-type lava with a very low viscosity, meaning it's super runny, pouring out from a single source or a huge rift, and just coating massive, sprawling regions of the planet in a continuous field of cooled magma.
Then we have the calderas. On Venus, simple, massive circular depressions caused by collapsing magma chambers are called corona. Hot magma from the mantle wells up, pushes the crust up, and then when the magma eventually retreats or cools, the whole structure collapses downward, leaving concentric fractures behind. When these collapse zones feature really complex, radially fractured patterns, scientists call them arachnoids, because, you guessed it, they literally look like giant spider webs etched right into the rock.
The planet's surface is also heavily warped by massive bulges known as topographic rises, which are pushed up to 4 kilometers high by mantle plumes. We generally categorize these into 3 main types based on what dominates them. You've got volcano-dominated rises like Bel Regio, rift-dominated rises caused by lithosphere thinning like Beta Regio, and corona-dominated rises like Themis Regio, which are driven by that magma chamber collapse we were just talking about.
So a crucial point here is that while Venus is totally dry, it still has rivers. The surface contains over 200 channel systems. One of them, Baltus Vallis, is over 6,800 kilometers long. That is literally longer than the River Nile on Earth. But these weren't carved by water. Since surface temperatures make liquid water totally impossible, these were carved extremely rapidly, likely in just 1 to 100 years, by incredibly fast-moving volcanic lava. They range from simple, single channels to complex braided patterns to compound systems that bifurcate and meander out as the lava loses energy.
Section 4. Bizarre geological oddities. Alien geometries shaped by pressure.
Now, because of the insane heat and atmospheric pressure, the geology on Venus takes on alien geometries that you simply don't see anywhere else. First up, we have tesserae. These are continent-sized highland regions that are considered the oldest features on the Venusian surface. They are heavily deformed, with incredibly complex intersecting patterns of ridges and grooves. To understand how rock behaves under 872 degrees of heat, scientists suggest imagining it acting more like peanut butter trapped beneath a thin, strong layer of chocolate. It just warps and bends in wild ways.
The crushing pressure also alters exactly how volcanoes erupt, resulting in completely bizarre shapes. We have pancake domes, which are exactly what they sound like, flat-topped, steep-sided volcanoes up to 38 miles wide. Then we have tick domes, which have radiating spurs on their edges that make them look uncannily like a blood-feeding tick. These bizarre shapes are formed by the sluggish extrusion of highly viscous, thick lava just struggling to push out against that crushing 93-bar atmospheric pressure.
Now, as we scan the surface, a glaring anomaly jumps out. Out of almost 1,000 impact craters on Venus, there are virtually none smaller than 30 kilometers in diameter. Think about that for a second. Where are all the little guys? Why wouldn't small meteors be hitting the planet?
Well, the answer lies in the atmosphere, which basically acts as a brutal meat grinder. When a small meteoroid enters the atmosphere, the insanely high friction and extreme pressure rapidly decelerate it, physically flatten it, and tear it apart. The rock fractures and literally melts in midair before it ever has a chance to touch the ground. Only the truly massive space rocks survive the journey down to leave a crater. It's nature's ultimate shield, but a completely terrifying one.
Which brings us to our final takeaway in this explainer. Venus and Earth were cut from the exact same cosmic cloth, born at the exact same time, with similar sizes and ingredients. Yet Venus became a toxic, 872-degree wasteland that crushes heavy metal probes in mere minutes. What set these twins on such dramatically opposite paths? And more importantly, as we look at the delicate balance of our own climate today, what can the doomed fate of our sister planet teach us about the incredible fragility of our own habitable world? It is definitely something to think about. Thanks for joining me on this explainer, and keep looking up.